So for them, I just want to say just hold on a bit because some of the topics might be same that we discussed earlier on the demo session. So today we are officially starting our course. So this is our day one. Okay. So yeah, let's not waste any more time. So before just joining in, my name is Kevin. For the people who haven't sat in for the demo class, I'll be your instructor for this particular course. I am CCNP certified in DevNet, that is automation part of CCNA. So I completed CCNA and a few automation courses inside Cisco as well. So yeah, let's slowly start with our session. I'm going to share my screen. Just let me know when you're able to see it. Hope you guys are able to see my screen.
Yes, sir, we can see.
Yes, sir, we are able to see this.
Great. So yes, as I mentioned, this is our day one for CCNA. So today, mostly we'll be discussing about the basic of CCNA. So what exactly are the concepts and what exactly are the things that or what exactly are the devices that we'll be concentrating on in this whole session. So that is like our 40-day session. So first of all, the things that you have to know are the different kinds of networking devices. So let's start over to that. Okay. Okay, just before that, these are the different topics that we'll be covering, starting with network fundamentals, the network access. Then we'll be moving on to IP connectivity and services. Then we have security part of it. And a little bit of automation and programmability. We won't be covering too much into automation programmability because as far as CCNA is concerned, what we need more here is about the networking side. So automation programmability will be there, but not to the highest end of it. And then by the end, we'll be having hands-on labs. And for hands-on labs, I would suggest all of you to make sure that you have your own system, not your office systems and all, because you might have to download a couple of softwares and install it inside your system, like Cisco Packet Tracer, etc. Okay, so yes, let's start with today's session. First of all, network fundamentals. So inside network fundamentals, the first topic that we'll be covering is about network components. So what exactly are network components? So yes, when I say network components, the basic thing is that what all kinds of devices that are being used inside to create a network. As simple as that, just as the word suggests. Okay. So some of the examples you might be familiar with, like routers, switches, even your computer can be considered as a network component. Reason being, it is somewhere, like it is part of that network which we are using to access a particular set of resources, right? Without that computer, there is like you can't see what you're accessing from this network. So these kind of things are known as endpoints. Your computer, your mobile phones, all of these are endpoints. Whereas these switches, routers, modems, all those kinds of stuff are known as access points. So you have your endpoints and your access points. We'll be discussing about that in the coming up slides, but I'm just giving you an overview. So yes, that's basically network components. So we'll be looking into different kinds of network components and how they are being used inside a network. So the first component itself, which comes to any network engineer's mind, the first one is router and second one is switch. So these are the major components that's always required. Because if you want to have some form of security or something, these two are highly required inside a network. So yeah, we'll jumping into it. So the first network component is a router. So what is a router? And what is its function? So yes, basically, A router is a device that connects and routes data between different networks. What that exactly means is that, let me just show you 1 second. Let's move this from here. Can I just reduce the size? Sure. Anyway, yes. Okay. So yes, imagine we have a network where we have to connect, let's say, 3 computers together inside the network. So we have system A, and in between the system A and system B, we are having multiple networks for different systems and all. So if you want to connect from A to B and A to B and C and everything, we'll be using something called a router. Let's keep this as like that. A router. The reason why we need this router is because without that router, what happens is if you're sending some data, we won't be able to understand whether it is going from our, let's say this is the sender and receiver. So without this router, if the A is sending something, it won't be able to know whether it is going to the intended receiver or to someone else. Okay. So for that purpose, what we do is we'll be having something called an IP address. So let's say for this, it's 192.168.1.5. Here we have 192.168.1.3 and 168.1.9. Okay. So the IP address of A is here, and IP address of B is this. So what basically happens is when any system is connected to a router, the router will automatically provide them with this IP address and it will be stored inside a table over there. Okay. And then when A wants to send something to B, it will be mentioning, I want to send this particular data to this particular IP address. So it will be sent to the router. Router will be finding out where that particular IP address is and then forward that data to the right receiver. This particular thing is known as routing. Like there are networks when we have to use multiple routers and we have to jump from one router to another router. Those kinds of concepts we will be covering. But for right now, this is the basic idea that you need to get. When you're sending a data from one location to another location, to make sure that it reaches that particular location, we need a router to give it the right details or the right make it understand the right path. Okay, hope that was clear on what a router is.
Yes, sir.
Thank you. So yeah, so it has like this is the basic function of router, but it does has multiple functionalities which we are going to go through. Some of them are mentioned here. The major ones are mentioned here, like packet forwarding. That is, the router has the ability to forward these sets of packets. These packets are basically the data sent from one location to another, which are divided into small pieces because we won't be able to send that entire data in a single packet because the size will be too large. So for those purpose, this entire data will be cut into small pieces and then would be sent through a set of packets and they will be forwarded from one location to another location using a router. And routing decisions, that just means like the router decides which path to take for sending this particular data. And network interconnection. So network interconnection is something. Okay. So the network interconnection basically means that by using router, you'll be able to connect multiple networks. So if you have a network we have like 5 systems in one network and 10 systems in another network. If you want to interconnect them, we can use a router and connect them together. Okay, so that is something called network interconnection. We'll be discussing more on the different types of its functions. So yeah, here we have it. So yes, first of all, we have packet forwarding for router. So packet forwarding, again, as I mentioned, this router forwards data packets between networks based on the destination IP address. That is our intended address. In earlier case, it was B. From the example I showed earlier, it basically means if you want to send A to B, this packet forwarding makes sure that it reaches B. Okay. The next top point is network address translation. So these routers can perform NAT or network address translation to map private IP address to a public IP for internet access. For example, let's say, uh, all these websites and everything that we access, these are basically some data stored over someone else's computer or someone else's server. So over there, if you want to access it, you saw earlier when I was giving an IP address, these kinds of IP address basically is like 192.168 dot something something or 10.6.5.2, something like that will be addressed. So you won't always be remembering the exact IP address of the data that you have to access. So instead of that, what people do is people will be replacing these IP address with some kind of domain names or URLs. The easiest example that you can understand it would be google.com. So this google.com is basically an IP address which is converted into a domain name. Okay, so when we are giving this domain name, what happens is that this request is going to that router, and router will be translating this google.com into a private IP address. Okay, like 192.168.1.7 or something like that. And it will be requesting data from that particular IP address. So all the data from that server will be collected and then it will be sent back to us. Okay, so that particular way of converting this public IP into this, like able to translate this public IP into this private IP is known as network address translation. Okay, hope that's clear. And next, in case of any doubts, please feel free to come off mute and ask, okay? Okay, so yes, the next one is something called routing. Yes.
Sir, public IPs means only the domain names are the public IPs, or any IP addresses are also considered as a public IPs?
Yes, we can have other kinds of public IPs other than domain names. I just mentioned that for easier able to understand much faster if you mention just domain name. So yeah, your question is pretty valid. You can have other kinds of public IPs. For example, let's say at your home, if you have a Wi-Fi connection. Okay, so if you go to your browser and search what is my IP, you'll be getting a particular IP.
Mhm.
Okay, if you just go to Google and just search, if you have some doubt, just go ahead and search it on. So you'll be getting an IP address. That particular IP address is your public IP. Okay, that would be in the same format as you mentioned right now. Let me just see if I can. Okay, what is my IP? So you see something over here, right?
Yes.
That is my public IP, your public IP address. Okay, that's my public IP. And at the same time, can go to my CMD and I open my CMD. Give me a second, it's loading. Okay, And here you can just find your public IP as private IP. Okay, config. Give me a second. So you see something over here?
Yes, sir.
IPv4, that's my private IP. Okay, so my public IP is something that is given to me by my ISP or my service provider when I'm connecting from my Wi-Fi to the outside. And this particular IP address is given to me from my like network device. This is the internal. So if I have my mobile connected to the Wi-Fi and I do the same thing on my mobile, I'll be able to find the private and public IP for that as well. Okay. Got the basic idea?
Yes, sir.
From the router, the connection goes to outside, right? That part is public IP. When the connection is coming to the inside, for all the devices inside our houses, that connection is known as your private IP.
Okay, sir.
Okay, that was a good question. Okay, so I hope you got the idea on that. And yes, moving to the next one, routing. So this is what I just mentioned earlier. Routers like make decisions on like which path it has to take to travel between networks using routing protocols. So yes, let's go on to that. So basically what it does here is that, okay, just quickly draw something. So this is our computer A. And we have computer B, and we have let's say 3 routers here: router 1, router 2, and router 3. So computer A is connected to B in 2 paths, that is R1, R2, and computer B, and R3 to computer B. So basically what this routing does is that, okay, sorry, my bad. I think we need one more over here. This is our computer A, and this is our router 4. Okay. So basically what it does here is that computer A will be connected directly to a router. Okay. And when it's connected to this router, and this router will be having all the devices connected to it and all the paths it takes. All this data will be stored inside R4 in a table. Okay. We'll go further into that later. But at the moment, yeah, let's assume that R4 has this table with all the data of all the connections happening from that R4. And we are sending a piece of data from computer A to computer B. So what R4 does is that R4 will be finding which is the shortest path. In this case, it has to go to R1, then R2, and then computer B. But in this case, it goes to R3 and directly to computer B. So this is the shortest path. So R4 will be able to make the choice of choosing the shortest path from computer A to computer B. Okay. This decision-making ability is known as routing. So this decision-making will be dependent upon multiple aspects, all of them which we'll be covering soon. So I hope this is clear, routing is clear.
So, sir, if I understood correctly, in routers mindset,
Yeah, sure.
the shortest path is the one which has the least number of routers connected in between the source and the destination.
Exactly, yes. The least number of devices,
least
not just routers.
Routers of the devices, which can be switches, routers.
It can be switches, routers, hubs, anything.
Okay. I was thinking this routers, but this clears my question. Thank you so much.
Yes, it can be any kinds of access point devices. Okay. If you are having a computer connected to this router, that doesn't count. That won't be counted. But in between this computer and computer B, if there is any kind of
Networking
access,
device.
yeah, networking or access point devices.
Oh,
Okay. Again, that was again a good question. So hope we are clear on them.
So, sir, it will only store the IP addresses of routers, or also it will store the IP addresses of systems.
Everything will be stored. IP address of system, everything will be stored.
Okay.
Like it will be matching that its IP address and its MAC ID. Okay.
Okay.
Yeah, we'll be going through that particular table details. It's called ARP. We'll be discussing that topic. Like it's actually a big topic coming up. So yeah, we'll be discussing about that. No worries. Okay, hope we are clear on that. And then we have interconnecting networks. Yeah, that's what I mentioned earlier, where you can connect multiple networks connected to multiple devices, and you can bring it all together by using a single router. And then subnetting. So subnetting is a process in which, let's say, a router can divide larger IP networks into smaller subnets for efficient address allocation, and you'll be able to easily group different sets of network, different sets of computers as different networks under the same router itself. So by using one router, you'll be able to divide the devices connected into different networks. So let's say if you have one router, inside that itself, you'll be able to run multiple networks. Okay. That particular method is known as subnetting. Again, an important topic that we'll be covering. We will be going through how this subnetting can be done. And all. So then we have firewall. So routers can function as basic firewall by filtering traffic based on rules mentioned by something known as access control list. So it's kind of like, let's say this router will not pass a specific types of protocols, or specific types of connection will be can be avoided by using this ACL or access control list. So in that way, the router can act as a firewall. Then we have gateway. So gateway means that the routers serve as default gateway for devices in a network, directing different traffic from outside or some other local networks. So in the earlier example, you could see I was connecting that computer A to router 4, right? Basically just that. That router acts as a gateway for this particular computer. And then we have DHCP, or Dynamic Host Configuration Protocol. So here the routers can provide IP address and network configurations to device inside a local network. So this is what I just shown you. You could have seen when I opened my CMD, you could see one IP address over there, like private IP. That is done by using Dynamic Host Configuration Protocol. That particular modem that I'm connected to, it's automatically giving me an IP address. So any device in my home that is connected to that Wi-Fi will be having different IP address, which is automatically given by that particular modem, or in this case, router. Then we have logging and monitoring. So these routers generate logs that allows monitoring for network traffic and device performance. So basically, whatever events that happens in case of any kinds of troubleshooting or anything, all those data will be logged and monitored by our router automatically. Or if you want, you can also have the option to set up different kinds of alerts based on thresholds and everything inside these kinds of routers. And yes, next, I'll just go a bit faster because this is basic factors of a router. So in case of any doubts, feel free to ask in between. Okay. So security, again, this router enhanced network security by controlling the traffic flow and it prevent any kinds of unauthorized access. Basically, what we mentioned in firewall and firewall about ACL. Then we have load balancing. So some routers support load balancing to distribute traffic across multiple links or paths. So basically what happens is if you're having too much data to send from one point to another point, it will find all the different paths that are available and send, it will divide the data into small pieces, and all the data will be sent through multiple ways. So by doing so, the data will be sent faster than it would have gone if you are sending it in one particular path. That particular method is known as load balancing. Then we have virtual private network or VPN. So here routers will establish this VPN connections for secure remote access or site-to-site connections. Basically for privacy requirements, you'll be using VPN. So yeah, these routers has the option to set up these kinds of virtual private network to make sure that there are no external entity that is looking into your activities. That is the requirement, main requirement of virtual private network. And yep, next we have dynamic routing. So here the routers use dynamic routing. Sorry. Any doubts? Okay.
Sir, hello, sir.
Yes, go on.
Sir, I'm Deepak.
Okay, go on, Deepak.
Yeah, sir. Access point can do routing or no?
So access points, what I mentioned by access point is that different devices, like there are different devices under access points. So for example, router itself is an access point. Okay, so that can do routing, and layer 3 switches. So layer 3, yeah, layer 3 switch again is an access point. So there are two types of devices. One is access points and the other one is endpoint. Okay.
Yeah.
So
we are seeing here some access point is there. We connect Wi-Fi, so it cannot do routing.
Not all access points. No. For example, let's say layer 2 switches. It is an access point, but it cannot do routing. I'm not saying all access points can do
and
routing.
And also firewall can do routing, right?
Firewall has the option to do routing, yes.
Okay, sir. Thank you.
And what I mentioned earlier, what's not access points can do routing, like routers, layer 3 switches, etc. These are access points which can do routing. There are other access points like your normal modem or your layer 2 switches. So these does not support routing. They only have the option to like connect and use it. So whatever data sent to it could be sent to multiple devices. It doesn't actually have the option for routing. Okay, cool. That was clear on that. Then we have, yes, dynamic routing. So here the routers use dynamic routing protocols to adapt to changing network conditions. That basically means that if you're adding more routers or more switches into a network, that means the table that we mentioned earlier has to be reset, because there are new entities that are being added to this particular network, right? So that means the pathways or the distance from one computer to the other computer might have already changed when you're introducing new routers and like switches, hubs, or anything. So again, so this dynamic routing can be done using routers. So router will automatically identify all the devices added and create a new table. Then we have something called, okay, somebody's mic is on. Please try to be on mute. Okay. Thank you. So yes, the last one is static routing. So routers can be configured with static routes for specific destinations. So this is mostly done for like high secure systems or high secure networks, which basically means that you have to set up a particular path for sending data from one system to another system. Whatever changes or whatever systems are added in between, the router does not care. If you are setting it up for static routing, it will only follow the path that is programmed into it. That particular method is known as static routing. It's mostly used in financial establishments like banks or military purposes, etc.
For more security.
For more security, exactly, yes. Okay, moving on. And yeah, these are some of the hardware components. Yes.
Sir, what the difference, like router and switches are both are same or it's a difference, sir?
There are difference. There are definitely difference when it comes to like routers and switches. So as I mentioned, the basic requirement of a router is like the routing purposes and all, for like being able to decide where we have to send this data and everything. When it comes to switches, so it is let's say it is basically used to divide a network into small networks. That is the main requirement of switch. Although it does support sending data from one location to another and all those kinds of stuff, the major requirement of switch when it comes to it is to divide networks into divide network into small subnets. That is a major requirement of switch. And switch it has like a lot of different kinds of aspects. There are multiple types of switches, like as I mentioned earlier, layer 2 and layer 3, which I think we'll be discussing it in the coming session. Would that be enough, or do you need to get a complete idea right now? So let me just give you a small on to it. So as I mentioned, there are like different types of switches. So this layer 2 switches basically does is that it will make sure that the connection, or it will make sure that there is some kind of how to put this. Just give me a second. Yeah, so layer 2 switches basically does the connection part. So if you are having like 10 switches 10 systems connected to one particular switch, and you want to like divide it into 2 small networks. So what you basically do is that you have the option to access its Ethernet ports. Okay.
Sir, we got able to see your drawing session, sir.
Okay, 1 second. Let me just give you an idea. So this is our switch, and we are having, let's say, 6 systems connected to that particular switch. Okay, so this is computer 1, computer 2, computer 3, computer 4, computer 5, and computer 6. So all of them are connected to switch 1. Okay, so what we can do is we can just connect one of our endpoint devices. It can be a laptop, something will be connecting onto that switch. It will have a username and password. By using that, you'll be accessing that particular switch. Okay, once you access that switch, what you can do is that we'll be accessing something called a CLI, command line interface, and inside that you can access different ports of that switch, because all these systems are connected to different ports inside this switch. Okay, and by accessing these ports, you'll be able to make changes to its configuration. And in that configuration, you'll be setting, let's say, this particular port, these 3 ports under VLAN 5. And all these 3 ports will be adding it under VLAN 6. And according to that, they will be given different, let's say, IP addresses. Either you can statically give them a particular IP address, or automatically when you are giving this VLAN ID and you are restarting that particular switch, automatically different sets of IP address will be given to all 6 computers. So what happens is that this will form a subnet, and this again will be forming a separate subnet. So even though all of them are currently connected to the same switch, this system will only be able to communicate with computer 2 and computer 3. And the same way, C4 will only be able to communicate with C5 and C6. So these 3 can communicate with each other, and these 3 can communicate with each other. But if you are trying to communicate from C1 to C4, it will be blocked. So these kind of connections, this is the main requirement of when it comes to switches. Okay, being able to divide the set of systems into different networks. I hope we are clear over
Yes,
there.
sir, I understood about the switch. The router is L2 will not be there, so only L3 will be there. I think so.
Router is only on L3, yes, correct.
Right, sir.
Switch we have L2 and L3, and L1 we only have hubs. Okay.
Okay, sir. Right.
So, sir, what is L1, L2, L3?
That is layer 1, layer 2, layer 3. So these are the different layers in which this device works. So when it comes to L1, what it does is you only have the option to connect different devices. But when you come to L2, you have the option to connect devices as well as group them. Okay. And when it comes to L3, we have the option to connect, we have the option to group, we have the option for routing as well as security purpose. So these increasing layers means increasing its capabilities. Okay, so that is basically what's mentioned by layer 1, layer 2, and layer 3.
Yes, hello, sir.
Yes, go on.
Suppose we are having 2 switches, okay? And in
Okay.
one switch we are having 5 systems, and in other switch we have 5 systems. So
Okay.
suppose I want to access a system from switch 2. So for that requirement, do we require a router, or we can directly do a connection from switch to switch?
You can connect from switch to switch, no issues on that.
Okay, yes.
But for that purpose, what you have to do is you have to make sure the configuration done to that particular port is for switch. Like if you're doing switch to switch connection, you have to open that port and provide it with the required configuration.
Okay.
Okay. If it's done, then yeah, there is no issue. You can connect from switch to switch.
Yes. Okay, sir.
You don't actually need a router in between. No problem on that.
Yes.
Okay. So yeah. Okay, and then so these are some of the basic hardware components that you have for routers. I just added it so that you get the idea on what we are actually working on. So when it comes to router, the major components is CPU, RAM, flash memory, and interfaces. So interfaces basically means your ports. Okay, the ports, Ethernet ports, serial ports, etc., where you'll be plugging in your cables. And depending upon the CPU power, you'll be able to get faster bandwidth and everything. And when it comes to software components, there are multiple types of softwares. So since we are discussing about Cisco, there are majorly 3 softwares. First one is iOS XE, then we have iOS XR, and then finally we have something called NXOS. So these different types of let's say software components or operating systems will be used depending upon where you want to establish this kind of network. For example, for automation purposes, we'll be using iOS XE. But if you want to set up, let's say, a data center or something like that. For that purpose, we'll be using NXOS and all. So depending upon your requirement, you have to choose what device you need and what kind of software or operating system you need. Okay. Yeah, that's mainly it. Then we have ports and interfaces. So different ports will be having different functions. For example, let's say there are particular ports which we are only using for broadcasting purposes, and there are a particular ports which support security, etc. But when it comes to most of the current routing devices, you actually have the option to like program it so much that you'll be able to change its default functionalities. So we'll be discussing about these ports and interfaces soon. So the main thing you have to know about these ports is that by using these ports, you'll be connecting to your different devices. Some of the routers won't even connect. You won't even use the routers to connect to a endpoint. Most of the connections from the router will be going to some switch, like when you're working inside a company or something. From the router, most of the connections will be going to multiple switches, and from switches, you'll be connecting to your system. Okay, this is done mainly to make sure that the data being sent is being routed correctly. Okay, so yeah, that's basically
Sir?
about. Yes.
Hello, sir.
Yes,
What is the function? What is the function of RAM, flash memory?
So that's basically where you would be the RAM and everything. As I mentioned, it has to do some kind of routing. It has to do different kinds of processing inside our router, right? So for that purpose, we need some kind of RAM or some kind of brain inside our router. So CPU and RAM is basically for that purpose, and flash memory is basically where you'll be storing all different kinds of tables. You'll be having something called an ACL. You'll be having ARP files. So all these files has to be stored inside the router. So for that purpose, you'll be having flash memory.
And sir, ROM. What is ROM?
Here we won't be requiring ROM as per se when it comes to router, but ROM is basically your flash. I mean, not flash. Basically your what you say,
BIOS memory.
Yeah, memory store. And in this case, when it comes to like routers nowadays, ROM is not much of an thing that you have to look into much, because the only place where you'll be making any changes is that once you access this router, you'll be getting your CLI, or if you are using a dashboard, there you'll be having access, and all the required automation or all the required programming you'll be doing directly over there. Okay, and in case if you want to increase its bandwidth also, or in case if you want to increase the processing speed, the only thing you might be changing is the RAM. Nothing else would be much of an issue on that.
Okay, sir. Thank you.
Yes, hello, sir.
Yes, is this?
Yes, sir, routers basically, we can directly connect our systems to routers also, no? So basically, switch will be required only for expansion of the network, like to connect more devices. Is that correct?
That is correct. The thing is, like I mentioned it earlier, the other ways, because router is way costly when it compared to switches.
Yes.
Okay. Okay, so when it comes to that, the companies or everything, they won't first like spend on routers. They prefer to use some form of switches. So after, if they are requiring some form of static routing or something like that, they'll be going for routers. But the question you asked is absolutely right. If you want to connect an endpoint device to the router, there is no issues on that. But when it comes to economically, it would be like a little bit redundant. That's it.
Yes, yes. Okay, sir. Thanks.
The question is right. Like if you want, routing, and if you only have like 10 or 15 systems, then you don't have to like get any kind of switches. You can get a router and then you can set up your network directly on that. No issues.
Sir, what is the difference between the switches and the bridges? Is the bridges different? Is the switches different?
Sorry, you want to know about difference between bridges and
Switches.
okay. So as I mentioned, bridges basically is something that you only use to connect, let's say, multiple networks. That's why we use bridges. Okay. But when it comes to switches, it's not that. The main reason why we are using a switch is to like connect devices into a network, and also to divide these different devices into subnets or subgroups. But for example, let's say bridges is something that you use to create one network, whereas switches is something that you use to create one network, whereas bridges is something that you use to connect multiple networks. Okay,
so it's like it's a bridges is a hardware and switches is a software. We can think like that.
Exactly, both of them are hardwares. Like switch and bridge, both are hardware. Let's say, okay, give me a second. So let's say we have 3 computers here, C1, C2, and C3. The main requirement here we have, okay, switch. By using switch, we'll be able to connect C1, C2, and C3 into one single network. Okay. But at the same time, and if you're having another switch 2, which has C4, C5, and C6. So this is switch 2, and by using switch 2, we can connect that to form this is network 1 and network 2. So by using switch 1, we are connecting C1, C2, and C3. And by using switch 2, we are connecting C4, C5, and C6. But by using a bridge, you'll be able to connect these 2 switches together. So basically, 2 networks are being connected together using a bridge. I hope you got the idea. We won't be
through router, right?
Router also we can connect. No issue. If you are requiring programming or if you are requiring routing purposes, you can use router. If that is not required, if you just want to connect 2 networks together, you will be using bridge. Okay. We won't be connecting any systems directly to the bridge. Bridge is something that we are using to connect 2 different networks. So either 2 switches or 2 routers or 2 hubs will be mostly connected to the bridge.
And sir, why we are nowadays we are not using bridge?
Because the security in bridge is very low. Like if anybody could easily get access to bridge, there are like literally no security services when it comes to bridge. If somebody has a laptop and you are plugging in your port directly into the bridge, he'll be getting access to the entire system. Okay, that is why bridges are not being used nowadays.
So mostly we'll be using switches, not the bridges. So bridges will be using very frequently. Am I correct?
Bridges are something that we won't be using. Switches are what we are using frequently. Okay, we'll be using switches to set up different types of network. But bridges, the reason, as I just mentioned, due to security issues and even sometimes data loss, we are not using bridges much. Instead of bridges, most of the time right now, we are using routers.
So it's an outdated hardware, just like hubs.
Yes, bridges are also kind of an outdated hardware. Yes, go on.
What is Adreno?
What is?
Adreno?
Arduino. You're asking about Arduino. So Arduino is just like how to put this. It's just a chip, and it really doesn't come inside CCNA. Anyway, since you asked, Arduino is just a basic, like how to
It's
say,
a motherboard.
yeah, close to that, exactly. That is something that you are used nowadays. Mostly it's used by students for like making small kinds of processor projects and all. It has the ability to run specific set of codes inside that PCB. And yeah, that's mainly what we are using Arduinos nowadays. I'm not sure where you got that right now.
I have it.
Okay, you have an Arduino. Okay. So like it's something that, yeah.
Kevin, this is Roundry. Can you explain what type of protocol that switch is using for routing the packets?
What kind of
protocol? Does switch uses any?
Okay, you want to know like what kind of protocols the switch is using
Yes.
for like routing network, those kinds of stuff.
Yeah.
So yeah, the switch can actually use almost all the different kinds of protocols, like let's say EIGRP, like IGRP, RIP, routing information protocol. All of them are possible inside switch, mostly. So like you want to know all the routing protocols. Again, we'll be going through that in later, but just for the sake of it, like we have RIP, RIPv2, IGRP, all these protocols are possible.
Yeah, Kevin, one question. So basically the router is a switch, right? L1 or L3 you said?
Router is not a switch. Okay. What I mentioned earlier was that we have two types of switch. One is L2, the other one is L3. L3 supports routing. That's it. It's not a router. That's a switch itself, but it has the option for routing within itself. That's it.
Okay, okay. So what about access points? How can you explain it?
So again, access points are just few devices which are basically used to connect different systems or different devices inside a network. Okay, that's the example. Like router is an access point, switch is an access point, hub is an access point. Because by using all this, you'll be able to connect different devices together inside a network. Okay, it just gives you access. These are the points which gives you access. The one way you can study is about comparing access points and endpoints. Okay, so as I mentioned, access points are devices which connect different devices together, and endpoints is where the network terminates. The endpoint is where you are accessing the data. So for example, your computer or your mobile.
Okay, now I want to connect to a different network, like one side is Airtel and another side is Jio. What kind of device I need to connect? Like it will be switch or within a router we can connect it?
I'm sorry. I didn't get that question correctly.
I want to connect to a different network.
Network from what?
Like Airtel, and one more is Jio.
No. What I'm saying is, I understood you want to connect to different networks. I'm asking you, like, so this connection is coming to your home through a Wi-Fi, right?
Yeah.
So you want to connect those two modems together.
Yes.
It's not exactly possible, and you should not actually do that, to be honest. The reason being, they have a lot of like firewall protocols and everything that they're mentioning. But if your requirement is that you need to connect two networks to your device, like if you have a computer And if you want to access both of them in your computer at the same time, if that's your requirement, what you can do is make changes to your system. Okay. On that system, you have the option to connect to multiple devices. But if you're trying to connect two of these access points together, that could create issues. Like one of them could be faster, one of them will be using a specific set of controls and all those kinds of stuff. So it is preferred not to do that. But if you actually want to like directly connect both of them together, preferably you could try a switch.
Switch.
Yeah, the only thing you could be able to do it, you'll be able to communicate between devices, between these networks, but you won't be able to get any fast and speed or anything like that. Nothing of the sort is possible.
So basically, we can say L3 device and L2 devices, like basically L3 devices forward the IP address and L2 devices forwards the MAC address, right? We can say.
Yes, yes, you can say that. Yes, that's a very good point.
Sir, access point is L2 device.
L2 and L3 both can act as access points.
Okay, sir.
Okay, so any device that can connect any other two devices together into a network can be considered as an access point.
But if you want to connect two different switches, we need a router in between of that, because we can't connect one switch to another switch directly. Is that what I understood? Is it correct, sir?
No, if you want to connect two switches together, it's possible. There is no issue onto that. But you, as I mentioned earlier, you will have to configure those ports correctly if you want to have that connection together. So, like there are multiple places or companies which actually uses only switches. They won't be having any routers. What they'll do is they'll have a central hub, that is a central switch, and from that switch, multiple switches will be connected.
Yes, we are using the same thing. That's why I asked this question.
Yeah, that's what I'm saying. Like you don't need a router for that purpose. You can just use this central switch and connect all the other switches directly to that. There is no issue on that. You just have to make sure that the central switch is configured correctly for that particular purpose. If you have the option to access that switch, just go to that port and see the code over there. Okay.
In L3 switch?
Yeah, L3 switch. You can actually see that that particular port will be having a particular set of codes which gives access to whichever switch that port is connected to.
Okay.
From that set, you'll be able to see a set of codes. So depending upon where you're working or who programmed it, there will be slight changes, but most of them will be pretty much same. It's mostly either you are using HP or Cisco, right? If you're having a central switch.
We are using Juniper and Aruba.
Okay. Okay, so most of the doubts are cleared. Let me see where we stopped earlier. Yes, we stopped at. Okay. Yeah. Anyway, let's just finish off these topics. Can we just take like 5 to 10 minutes more? Hope that's fine.
Yes, Kevin.
Okay, thank you. So yeah, these are some of the protocols that we mentioned earlier when someone asked a doubt on routing, like what are the different routing protocols that can be used. So these are RIP, OSPF, EIGRP, BGP. So all of these routing protocols will be going through each every one of them in the coming session where we are discussing about that protocol. I'm just showing you that these are the protocols that we are using for routing protocols for routing purposes. And routing methods can be static or dynamic. So we discussed static and dynamic earlier. Static means that there will be like one particular path that is programmed into that router. So whenever any data is coming, it will only follow that particular path. Dynamic means the router will be checking, okay, which which method should it use to send that data faster and more secure. So for that purpose, we are using dynamic routing. So if the router has like 3 parallel ways, it will divide the data into 3 and send through each of those ways. So all of them will be reaching there together and the data will be sent much faster. Then we have something called router management. So here what we basically do is that if we have a system connected to that router, you'll be having multiple options. Either you can use your CLI. So CLI is basically a CMD that I just shown earlier. So by using that CMD, you'll be able to access that router by giving its domain name or URL. So by giving that URL, you'll be able to connect to it using multiple protocols. Either you can use SSH, Telnet, or HTTP. So all of these are possible for you to use. Either you can use your system CMD, or you can download something called PuTTY, PUTTY. So by using that, you'll be able to connect to your router and then gain access to it, make all the required changes on that. And next one, we have something called monitoring tools. So these tools, basically what it does is that it will check the traffic inside our router or our connections between the ports of the routers. This is done mainly to understand whether someone is accessing the data maliciously, or if whether some kind of data leak is happening over there, or if there is any kind of, let's say, unexpected data transfer happening over there. All of this requirement for all of this, we'll be using monitoring tools. And for that purpose, we have multiple kinds of tools. We have live tools like NetXMS, Logstash, etc. And then we have another option like all this data, all this log will be stored into a particular file known as syslog that you can see over here. So you'll be checking that syslog frequently to understand whether if there is any changes made into that particular application. You can see some images. Okay. Fine. So yes, next we have firmware updates. So that just means like whenever we are working on a router, we have to make sure whether our system is up to date. So not just firmware, you have to make sure that your software is also up to date. In case, let's say if you're using any of the iOS softwares, there will be multiple up and coming distributions coming almost every year. So whenever there's something new is coming out, you have to make sure that the changes made to that OS is something that you require, and then make the update onto your router, and also at the same time, the base software, that is your firmware. So in case of any changes any new change or new update comes up, you have to make sure those get updated as well. Because most of the time, when somebody is creating some kind of virus or something like that, this firmware gets affected. So once that's affected, what happens is that there will be a particular set of team who will be working on updating this firmware to like completely discard this virus, or like fight against this virus. So in that case, you have to make sure that your system is always updated with the latest firmware and the latest software. And yes, so that's basically on, that's basically on routers. So today
This
I think
update,
this
update, how long we can do, sir? Like, is there any lifetime for router and switches, or it is like we can use for only 2 years or 5 years in that case?
No. Subnetting is something that you're doing inside your hardware, like your switch. There is no subscription or anything like that for that. You can make it into any number of small networks. Okay, there is no issue. Like once you have a switch, and on that switch, you have the option to divide it into as many networks as you want.
No, sir, not that one, sir. This whatever we have routers and switches, sir, Whether is
Okay.
there any lifetime for like we need to use for 2 years or 5 years, this firmware update and all? How can we know that
Okay.
future we don't have any option, right?
Oh, you're talking about supportability. Okay, so what
Yes,
I'm
sir.
saying is like, right now, I think the latest update came somewhere close to 2023 February, I think. And for almost all the devices which have been, which has came out for the last 20 to 25 years, they've given out firmware. So pretty much, I have to assume, like, I'm not saying that's exactly what's going to happen. When it comes to Cisco, I have to assume, so if you buy a system which is currently in use, they will definitely give you an update. So if you have a switch which is produced maybe like in the last 10 years or the last 15 years, you are definitely, you'll be able to find firmware updates.
Okay, sir.
Okay. So for today's session, I'll be winding up my session for today. So what I'm going to say is that tomorrow we will try to go a bit more faster because we haven't even completed half of what I thought I will be completing today. We just finished on routers. So preferably tomorrow